Today we're going to be discussing the properties of exponents. And there's just a few things that we want to make sure that we have when we are dealing with these properties of exponents. And the first of those is that we really do need to make sure that we understand the why this works. Now, there are several properties that we need to discuss. The first of which is the product of powers. And the product of powers property basically states that if I have a number raised to two different powers, but I'm multiplying those numbers together, I can just add those exponents. And this gives a quick method for finding the square roots and cubed roots as well, which we'll discuss a little bit in the later in the video. Then we have quotients of powers. This property is very similar to the previous one. If I have the same number, if I have a number to two different powers and I am dividing them, and that number does not equal 0, then I can subtract the exponents. And as I said, the big thing is a cannot equal 0. Okay. Then we have a power of powers property. And this property says if I have a number being raised to a power, and then I raise that entire value to a power, what I end up with is that original number to a power that is the product of our two exponents. We have the zero power property, which says if I take a number and raise it to the 0 power, I get 1. The only exception to that rule is when a equals 0. And what that actually ends up equaling is something that we do not have the mathematics to actually show quite yet. It's going to be a few years before you get to that point. We have a negative power property, and this states if I take a number and I raise it to a negative exponent, what I end up having is the reciprocal of that number to the nth power. And I'm actually going to write that in a slightly different way. So that we can see that it goes to the entire reciprocal, not just the value. And then there's one more. And this is the one that will let us simplify radicals easier. Rational power property. And this tells me that if I have a to a fraction, I'm going to say m divided by n. So a is being raised to a rational exponent. This is the same thing as saying the nth root of a to the m. So, what are some ways that we can do this? Well, let's say we have the number let's get it a little, let's see, which number do we want? Let's say that we want to know what is the square root of 6,300 and we want this radical to be simplified, so we don't want an approximate answer. We want an exact answer. Now, we notice that there's not an index written here. And what that means is that our index is 2. So if we don't have an index showing, we have an index of 2, which means that we would, if we were using the method discussed in the previous video, factor this down, circle pairs, and then every pair that we have we can factor out. Okay. But since this has an index of 2, it means that I can write it like this. 6,300 to the 1/2 power. Okay. Now, 6,300 I can write as 100 times 63. 100 I can write as 10 times 10. That is a pair. We're going to leave it. 63 we can write as 9 and 7. And then 9 we can write as 3 and 3. So what we have here is 10 squared times 3 squared times 7, everything to the 1/2 power. Now, the power of powers says that I can distribute this 1/2 in. So that means that we have 10 to the 2 divided by 2. Yes, I know that it's 1, but we're writing it out this particular time, 2 divided by 2. And 7 still is 1 over 2, which means that this is the same thing as saying 10 times 3 times 7 to the 1/2 power, or 30 square root of 7. Now, this is just showing why the method previously worked. But that will do it for this video, and I will see you in the next one.